Now we're going to start an exciting part of calculus, and that's antiderivatives. You're going to realize that you know more of this than you think you do. Suppose I were to ask you to find a function f whose derivative is f of x, and then that's 3x squared. And you might think and go, aha, what if I let f equal x cubed? Then I know that the derivative with respect to x of x cubed is 3x squared. I'm good. So I can say that if f has a derivative of lowercase f, then f is the antiderivative of, lowercase f. All right. This is a definition. I want you to write it down. You never know when definitions are going to pop up. Function big F is an antiderivative if the derivative of f is equal to f of x for all x in your interval. Now, see if you can do these. Come back when you're done because we have quite a bit more to do. Now, let's look at theorem 4.1. If f is an antiderivative of lowercase f on an interval I, then g is an antiderivative of f on the interval I, if and only if g is of the form g of x is f of x plus c, where c is a constant. Now I'm going to kind of prove the easy way of this. I'm going to let g of x equal f of x plus c. And I'm going to let f prime at x equal f at x. Then I'm going to take the derivative with respect to x of g of x. And what you do to one side, you have to do the other side. Oh, my pen. All right, so this is g prime at x is equal to f prime at x. And the derivative of constant is always 0. Now, I know this is equal to lowercase f of x, so I can now say that g is an antiderivative of f because when I take the derivative of g, I get f. Now there's another more rigorous proof. I'll let you do it. It's in the textbook. Now, let's do another definition. When I say differential equation, I mean an equation that involves x, y, and y prime. It may be of the form y prime is 2x, or y prime is 2xy, or there doesn't have to be a 2 in there, or y prime y plus 3x squared equals 4x. I don't know. Okay, that's kind of an ugly one. But so I'm going to be using the phrase differential equation, and I'm not meaning anything mysterious, just that I've got some derivative with respect to x of y involved, along with my x's and y's. Now, let's look at solving a differential equation. Let's look at this right here. This is dy dx is equal to 2. Now, what function do we know that has a derivative of 2? If I let y of x equal 2x, I know y prime is 2. Aha! So I know that y is going to be 2x. Now it's plus some constant. So all of these functions right here are solutions to this differential equation. The slope is 2 for every one of these curves. You have to include this c. If I were to go back to the definition of the antiderivative, where g of x is f of x plus c, you wind up with what's called a family of solutions, or a family of antiderivatives, because y equals 2x is a solution, y equals 2x plus 1 is a solution, y equals 2x plus 2 is a solution. So you have a bunch of solutions. When we solve differential equations, there's not always just one exact answer. All right, pause the tape and answer the question. Come back when you're done. I'm not done with you. Now, let's look at for notations for antiderivatives and indefinite integration. So you need to know what I'm talking about when I say things. I know that if I let dy dx equal f of x, I can rewrite this as dy as f of x times dy times the differential. Now, we've already done this. And let's see if I can get back to my pen. And the answer is no. I just spaced this so horribly, it's not going to let me do it. So let me resize real quick. Apologize about this. Or not. Well, never mind. Okay. So if I use this notation, I want you to know exactly what I mean. I'm going to be writing things in the form of, let me go back to my pen. Okay, you're going to see this big S, and that is my integration symbol. Okay, this means I'm going to integrate. Okay, and you're going to see me write things of the form, the integral of f of x dx is equal to the antiderivative plus c. Well, there's my integration. F of x, I'm going to call my integrand. Dx is my variable of integration. F of c is my antiderivative, and of course c is my constant of integration. Now, the constant of integration is worth a point on every problem, so don't leave it off. At least not on the indefinite integrals. And it's indefinite because we don't have any limits, so we'll discuss what that means later. Now, integration is the inverse of differentiation, as differentiation is the inverse of integration. So basically all we're learning is the inverse of everything we've learned up until now. Now, I'm going to give you a list of basic integration rules. If I take the derivative of a constant, I get 0. And if I integrate 0, I get a constant. If I take the derivative of kx, I get k. If I integrate k dx, I get kx plus c. So you need to know these. You should be feeling a quiz. Memorize them. Now, what I want you to do is to apply the basic integration rules and check for a number of these problems. So let's see. I'm going to factor the 3 out because I can do that. 3x dx. And I don't know why my pen disappeared. All right, now I'm going to rewrite this as 3x to the first power. And now I'm going to apply the integration rule. For integration, you raise the power by 1 and divide by the power and add your constant. Now I'm going to check it. I'm going to check by taking the derivative with respect to x of 3x squared over 2. And what do I get? Well, I get 3 times 2 x to the first power divided by 2 plus 0. So this is just 3x. Aha! Worked. Let me try this one right here. Now the first thing I'm going to do is rewrite this. So this is the integral of x to the negative 3 dx. So you raise the power by 1 and divide by the power. So this is going to be x to the negative 2 over negative 2. Don't forget to add your constant. Now I'm going to rewrite this because this is just kind of ugly. So this is minus 1 over 2x squared plus a constant. Now I'm going to check. I'm going to take d dx of negative 1 over 2x squared plus c. Now, you remember for powers, I'm going to have another negative. So when I take the derivative, I multiply by the power, so that's negative 2 divided by 2x cubed plus 0, or it's positive, so I get 1 over x cubed. Now for this one, I'm going to integrate the square root of x. I'm going to go ahead and make this x to the 1/2. Okay, remember when you integrate, you raise the power by 1 and divide by the power. So this is x to the 3/2 divided by 3/2 plus c. Oh, this is just ugly. Let me rewrite this. So this is 2/3 x to the 3/2 plus c. I'm going to check it. d dx of 2/3 x to the 3/2 plus c is, let's see, it's 2/3, bring down the power, 3/2, x to the 1/2 plus 0, that all cancels, so this is just x to the 1/2. I'm on a roll. Now what about this one right here? I'm going to factor the 2 out, integrate sine x dx. Now the integral of sine is minus the cosine, so this is going to be minus 2 cosine x dx, or cosine x, plus a constant. Look what happens when I check it. d dx of minus 2 cosine x plus c is minus 2, derivative of cosine is minus sine of x. Okay. Now, you can see how this is going. If I just want to integrate x, then I integrate 1 dx. So this is just x plus a constant. When I have a sum, I can break this up. Okay, so this is x squared over 2 plus 3x plus c. Now you see I only have one constant here because a constant's a constant's constant. Same thing here. This is going to be the integral of 3x to the 4th minus the integral, dx. Am I leaving out my dx's? No. 5x squared dx plus the integral of x dx plus the integral of 7 dx. So this is 3 x to the 5th divided by 5 minus 5x cubed divided by 3 plus x squared over 2 plus 7x, and do not forget your constant. Now you may need to rewrite the function. This is the integral of x over the square root of x plus 1 over the square root of x. Algebra still works, folks. So this is the integral of x to the negative 1/2, or x to the positive 1/2 dx plus the integral of x to the negative 1/2 dx. Integrate both of these, and you get x to the 3/2 divided by 3/2 plus x to the 1/2 divided by 1/2 plus c. Let me rewrite this. So this is x to the 3/2 divided by 3 plus 2x to the 1/2 plus c. And I don't mind if you leave it that way. Now, the integral of f of x dx divided by g of x does not equal you can't split them up. So do not try this, because you can see that if I do take this division, it's not going to equal what we just got. All right. I want you to try these. Come back when you're done. Or finish your homework.